Hi everyone, this is a video about scientific notation. I want to talk about how to remember or how to figure out which way you're moving in decimal place. So many people like to remember whether you're moving left or right. Unfortunately, it's the opposite depending on whether you're going from standard notation to scientific notation or whether you're going from scientific notation to standard notation. Okay? So let me demonstrate what I mean by just doing some examples here. So let's say I start with the number 42,000. Okay, I'm starting in standard notation. 42,000 is in standard notation, and I would like to put it into scientific notation. So right now, the decimal place is starting here, and remember it needs to end up right here, because by definition, the scientific notation, there can only be one number, one digit before the decimal place. Okay, so our decimal place is starting here, and it's going to end here. So we're going 1, 2, 3, 4 units over. So that means that this becomes 4.2 times 10 to the 4th power. Okay, I'm going to use purple to keep track of the direction that we're using. So we moved our decimal place to the left 4 units. Okay, and we have a positive exponent right here, 10 to the positive 4th. Let's go backwards. Let's use the example 4.2 times 10 to the 4th power, and let's put it into standard notation. So this time we're starting in scientific notation, and we're going to standard notation. So if I take the number 4.2, the exponent 4 tells me that I need to move the decimal place 4 times. Am I moving it to the left or to the right? Well, in this case, I need to move it to the right. 1, 2, 3, 4 times. So my decimal place is starting here, and it's ending here. Okay, and just like last time, we have some blanks that we need to fill in with zeros. 1, 2, 3. So that means our final answer is 42,000. Okay, note that this time I moved my decimal place to the right. So my point here is that if you're trying to memorize left and right, the directions are opposite depending on whether you're going from standard notation to scientific or whether you're going from scientific notation to standard notation. So to me, a better, more useful way of trying to remember things instead of thinking about left or right is to ask yourself, do you have a value greater than 1 or less than 1? So, if I have a value greater than 1, then I know something. The first thing I know is that I know, that values greater than 1 have positive exponents. Okay, only values that are smaller than 1 have negative exponents. Okay, and then down here, I already have a positive exponent. Because I have a positive exponent, that means that I know that this value, that my ending value, has to be greater than 1. So if by accident, I'll put this in a different color here. Let's make it orange. Let's say I'm looking at the number 4.2 times 10 to the 4th, and I start moving it this way. 1, 2, 3, 4. And I end up with this number here. When I look at that, this is much smaller than 1. But that can't be right because I have a positive exponent. This positive exponent tells me that I should end up with a number that is much larger than what I started with. So that would tell me that I therefore went in the wrong direction. So my point is, if you start trying to remember left and right, it can get extremely confusing. And you'll see that that's even more true when we do the other two examples. So again, instead of trying to memorize left and right, memorize that values greater than 1 have positive exponents, and that positive exponents result in values that are larger than 1. All right, let's finish filling out this chart. So just for the sake of continuity, let's go ahead and use this example. Let's use 0.00042. Okay, so we're trying to get this into scientific notation. So our decimal place is starting here. Okay, where is it going to end? Well, if it ends here, remember that means that there would be 2 digits in front of our decimal place, which is in violation of the actual definition of scientific notation. So our decimal place has to end, it has to stop right after 4. So we go 1, 2, 3, 4. Okay, so we have 4.2 times 10, and just to play devil's advocate here, I'm going to put a question mark. Okay, so let's pretend that we're on a test or quiz or even a homework assignment, and we really aren't sure. We know we moved over 4, right? So we know that this is either going to be a positive 4 or it's going to be a negative 4, and let's just say we're having some sort of like brain fart here, and we just don't know whether it's positive or negative. Okay, so then remember we talked about thinking about it in terms of left and right. Okay, so I definitely moved my decimal place to the right. Okay, so hopefully you can start seeing that the left and right and using that as a rule is really not reliable, because over here I moved it to the left, over here I moved it to the right. Both places I was working with a value greater than 1. Over here I moved it to the right and I'm working with a value less than 1. So instead of thinking about it in terms of left and right, what I want you to think about is this number, this 0.00042, is it smaller than 1 or is it greater than 1? Okay, hopefully you can see that this is a value that's much smaller than 1. So values less than 1, by definition, have negative exponents. I apologize, it doesn't quite fit on the screen. And by definition, values greater than 1 have positive exponents. All right, so let's finish this problem. If this value is less than 1, which we said that it was, then we know that we should not end up with a positive exponent. Okay, it's a value less than 1, therefore we should end up with a negative exponent. So let's go the other way. Okay, so we're going to start this time with scientific notation. Okay, and we are going to convert this into standard notation. In order to do that, we need to move the decimal place over 1, 2, 3, 4 spaces, which, as you can see, creates some vacancies there for us. And we're going to fill in those vacancies with zeros. Remember I said in my last video, you can, if desired, place a leading 0 here. It's totally up to you. Okay, so my final answer is 0.00042. Okay, and this time we move the decimal place to the left. Okay, so you can see, just looking overall at this table, right, half the time we move it to the left, half the time we move it to the right, and it depends on whether we're going from standard to scientific or scientific to standard, and it also depends, right, whether we're working with the value that is greater than 1 or less than 1. So Instead of trying to memorize left and right, how would I know? How could I know just by looking at this that I have to move to the left? Well, the main way that I can know is quite simple, which is that if let's just say, use this orange color again, let's say I did move it to the right. Let's say I went 1, 2, 3, 4, and I ended up with the number 42,000. When I go and look at that, I know that I have a negative exponent. Therefore, I know this number is smaller than 1, and it's pretty clear that the number 42,000 is a number that is much larger than 1. So this cannot be a valid solution. If I start with 4.2, that is a number that's larger than 1. The only way to make it smaller than 1, to shrink this down, is to move the decimal place over to the left. So hopefully this video gives you some insight. Again, I'm giving you all 4 examples where you have positive and negative exponents, and when you're going from standard to scientific and scientific to standard. Okay, so look over these 4 examples. Okay, realize that half the time you're going to be moving the decimal place to the left, half the time you're going to move the decimal place to the right. Okay, and again, the main thing to remember, if you remember one thing, is ask yourself, is this number larger than 1? Then I have a positive exponent. Or, if you're down here, if you have a positive exponent, then remind yourself, that means you're going to end up with a number that's larger than 1. Likewise up here. If you have a value less than 1, then you know that it's going to give you a negative exponent. And if you start down here with a negative exponent, then you have to end up with a number that is smaller than 1, not a number that is larger than 1.